This video is on adding and subtracting rational expressions, part 4 in the series. Guess what? Adding and subtracting, just like, fractions. So, in order to add or subtract fractions, you must have a common denominator. The same is true for rational expressions. So let's get right in. Again, you still have to find NPVs. So every single time you do a rational expression, anything, you got to find the NPVs. Okay, so remember, I always start from easy questions and I work into difficult questions. So if you notice, the very first question, part A, has the same denominator. So therefore, all I have to do is add the tops. So 11 and 5 is 16 over 2x. And again, don't forget to simplify your answer if possible. In this case, it is 2 goes into 16 8 times. So that simplifies to 8 over x. To find our NPVs, we look at the denominator. Because they're the same, I only have to do this once. So 2x cannot be 0, and x cannot also be 0 because we divide both sides by 2. All right, easy one. Let's try this fun brown color. Next question here, if you'll notice, they have different denominators. So what do 2x and 3 both go into? I'm going to use 6x. So I'm going to change them both into 6x. What did I multiply 2x by to get 6x? That would be 3. But if I multiply the bottom by 3, I have to do the same thing to the top. So 3 times 3 is 9. To get 3 to become 6x, I would have to multiply it by 2x. So if I multiply the bottom by 2x, I must do the same to the top. So 4 times 2x is 8x. Now that the bottom is the same, I can subtract the tops. Because they're not like terms, I just have to write them as 9 minus 8x all over 6x. Do not simplify anymore from here because, again, this is a binomial on the top. The only thing that simplifies it is another binomial. 6x is a monomial, so I am done. Let's find NPVs. Again, 2x is the only thing in the denominator that has a letter in it. So I set 2x not equal to 0 and divide by 2 for both sides. Whoops. So x cannot be 0, and that's my simplified rational expression. Okay, let's go with pink. So if you look at part C, again, the denominators are different. So what we're going to do is see, does one go into the other? In the last example, 3 didn't go into 2x, and 2x didn't go into 3, so we had to multiply them together to get our denominator. But in this case, 2m does go into 6m cubed, so I'm not going to change the 6m cubed. Okay, so if I don't change the bottom, then I don't have to change the top. However, to make 2m become 6m cubed, I would have to multiply that by 3. So times by 3, and m times m squared to give me m cubed. Do the same thing to the top then. So 3 times 3 is 9, m squared n. Good. Now I have the same denominator. I can add the numerators. Again, they're not like terms, so I'm just going to write them. And again, addition, the order does not matter. So I can write this guy first, or I can write that guy first. All right, awesome. The denominators, again, because I can make 2m into 6m cubed, I just have to do one or the other. They're both monomials, so I'm going to get the same thing I always get. So 6m cubed can't be 0, divide by 6, m cubed can't be 0, and I cube root, guess what, m can't be 0. Okay, awesome. So there is my simplified rational expression and my NPV. All right, another color. I like this green color. Okay, good. Now, if you notice in this example, I have binomial denominators. The process is the same. If the denominators are the same, I can just subtract the numerators. If they aren't the same, then I have to make them the same. Good. In this case, they are the same. So I'm just going to subtract the tops. That gives me 9x take away 6 over 3x minus 2. However, 9x minus 6, I can factor 3 out of that. So I would get 3 times 3x minus 2. 3 goes into 9x 3x times, and 3 goes into 6 2 times. Lo and behold, I have a common binomial on the top and the bottom. Because that's multiplying and dividing, I can cancel those out. Remember, when you divide, it equals 1. So 3 times 1 is 3 over 1, or just 3. Okay, NPVs, 3x minus 2 cannot be 0. 3x cannot equal negative 2, and x cannot equal negative 2 over 3. Okay, so there's my NPV. Because the denominators are the same, I only have to do this once. And there's my solution, x equals 3. Fantastic. All right, different color. I like purple. Here we go. In this example, the denominators are not the same, so I have to make them the same. Because they're both binomials, I'm just going to multiply those two binomials together. You don't actually have to FOIL them together. You can just leave them written side by side. So that would be n minus 5 times n plus 2 plus n minus 5 times n plus 2. Okay, what did I do to this denominator to get this? I times by n plus 2. So if I times the bottom by n plus 2, I must multiply the top by n plus 2. So 3 times n is 3n. 3 times positive 2 is positive 6. Okay, to get n plus 2 to become this, I have to multiply it by n minus 5. But if I multiply the bottom by n minus 5, I have to do the same to the top. 5n times n is 5n squared. 5 times negative 5, 5n times negative 5 is negative 25n. Now that the denominators are the same, I can leave them that way. So that becomes n minus 5 times n plus 2. And I can collect like terms on the top. Because now the denominators are the same, I can just look at the numerator. 5n squared has no friends, so it's going to go first there, button. Negative 25n and positive 3n makes negative 22n. And again, the plus 6 doesn't have another like term, so I'm just going to add that on at the end. Okay, good. Now we find our NPVs. So we have two denominator factors. So n minus 5 can't be 0. Add 5 to both sides. N cannot be 5. And n plus 2 cannot be 0. Minus 2 from both sides, so n cannot equal negative 2. Good, so those are my NPVs, and this is my sum of my two rational expressions. Okay, I'm going to take this guy here. Obviously, I don't have enough space, so I'm just going to add a page, and I'm going to do that question on the next page. Let's do that one in blue. Okay, so we had 4x plus 1 over x squared minus 9 minus 9x minus 1 over x minus 5 times x plus 3. Okay, I think that's what that read. Yep, x minus 5, x plus 3. Okay, good. So again, I do not have the same denominator. I can factor x squared minus 9. It is a difference of squares, so that gives me 4x plus 1 over factors to conjugates, so x plus 3, x minus 3, minus 9x minus 1 over x minus 5, x plus 3. Okay, notice now that I have an x plus 3 in common, so my denominator for my answer has to have an x plus 3. In order for this to go into it, it also must have an x minus 3. And in order for this to go into it, it must also have an x minus 5. Okay, so what do I do to this denominator to make it become this? Well, the only thing that differs here is the x minus 5. So I'd have to times this bottom by x minus 5, but if I times the bottom by x minus 5, I must also times the top by x minus 5. In this case, you are going to have to FOIL those together. So 4x times x is 4x squared. 4x times negative 5 is negative 20x. 1 times x is plus 1x. And 1 times negative 5 is negative 5. Okay, minus Now, how is this denominator different from our common denominator? The only thing that's different is the x minus 3. So I would have had to multiply that by x minus 3. If I do that to the bottom, I have to do the same thing to the top. And again, I'm going to FOIL. 9x times x is 9x squared. 9x times negative 3 is negative 27x. Negative 1 times x is negative 1x. And negative 1 times negative 3 is positive 3. Notice that I put my second set of terms in brackets. That's because this is a subtraction sign out front, which means I'm subtracting everything inside the brackets, not just the first term. Okay, I'm going to run my negative sign through, and then we can start collecting like terms. So 4x squared minus 20x plus x minus 5 minus 9x squared plus 27x. Remember, when I multiply by negative 1, technically, it changes all the signs. Plus x minus 3. All over x plus 3, x minus 3, x minus 5. Okay, collecting like terms, 4x squared, take away 9x squared, gives negative 5x squared. Negative 20x plus x is negative 19x. Plus another x gives negative 18x. Plus 27 gives positive 9x. And negative 5 minus 3 is negative 8. All over x plus 3, x minus 3, x minus 5. You're thinking, wow, that was a really long question. I sure hope we're done. Well, we're almost there. Last thing we got to do, of course, is find our NPVs. So we have x plus 3 in the denominator. That can't be 0. So I'm going to subtract 3 from both sides. X cannot be negative 3. We have x minus 3 can't be 0. That's in our denominator. So again, I'm going to add 3 to both sides. So x cannot equal positive 3. And we have x minus 5 in the denominator, so that can't be 0. I'm going to add 5 to both sides, so x cannot be 5. Okay, so those are all my NPVs, and I do believe now you are finished. Okay, so if you'll notice there at the bottom of the page, we have page 249 for you to work on, because the only way to get good at this stuff is to practice. So good luck. Make sure you show your teacher when you're finished.